P series is the quickest, easiest test that we're going to learn here. If you have 1 over n raised to a number, where that number is a positive number, if it's bigger than 1, it's going to converge. If it's less than or equal to 1, it's going to diverge. So if you have 1 over n raised to a number, that's a P series where that P is equal to 3/2. So I'll just jot that down. That's really the only work you got to show there. And then you're going to have memorized. If it's bigger than 1, that's going to converge. So you're going to write converge or diverge down. And then you're going to tell me the test that you're using here, where you're using the P series test. There you go. So that's all the work that you need for that. All right, so if it doesn't look like that, you are allowed to use legal algebra. That's n to the 1/2 over n to the first. You can subtract your highest exponents, and you can turn that into 1 over n raised to the 1/2. And now you do have 1 over n raised to a number. So that's a P series. So your P is going to be 1/2. And then that number is smaller than 1. So that means that's going to prove diverge. And then what we're using here is the P series test. And then sometimes I just threw this one in there because if it's equal to 1, sometimes people get confused on whether it's converge or diverge right there. So if it's equal to 1, I just want to throw that one example in the notes. If it's equal to 1, that's where the bar is at. So if it's equal to 1, that's going to be a diverge. And we're using the P series. So just like the geometric test, so you got to tell me the R value, tell me converge or diverge, what test you're using, tell me the P value, tell me converge or diverge. Real quick and easy. And the nice thing is we'll use this on some more complicated looking tests in the future. So we got to make sure we know that down. The reason I throw this one in there too, there are some, this is called the harmonic series when that P is equal to 1. So what goes off in my head, I just remember learning that in college a little bit. The professor would call that like a divergent harmonic series. The harmonic series are always diverge, and so it just kind of helps me remember when P is equal to 1, that's a divergent harmonic series. That for some reason that just helps me to remember that diverges. So if that helps anybody, that's fine. But if you actually like look up harmonic series, there are musical applications to that, scientific applications to that, where I remember this girl one time brought in this violin at the end of the year, and she was doing something, mapping the notes on her computer when she was playing it, and how when it went off of there and it diverged, like something was just off with the notes there. I don't know exactly. It was, but it was kind of super interesting how she connected the math with the violin somehow. Also, make sure you know if you ever get stuck, remember this n is on the bottom. So what helps me if I ever forget converge or diverge, since it's on the bottom, if I have like 1 over n to the 80th, think about that bottom is going to go to infinity a lot quicker than like 1 over n to the 1/2 there. So if you got 1 over n to the infinity, or 1 over n to the 80th, 1 over n to the 1/2, 1 over infinity, there are different degrees of infinity, right? And so that's going to be like that's going to go to infinity so much quicker. And so that has a better chance to converge right there because it's going to approach 0 a lot quicker than this guy right there. All right, so there you go. P series, simple and easy.